Today's video is about the distributive law. So this law helps us figure out what to do whenever we have a situation like this, where we have something, it can be a number or a letter, in front of brackets, and we have two or more things on the inside. So for example, you might see the distributive law used in a question like this. Now, the distributive law helps us to simplify polynomials. So this is a tool that we use for simplifying. That being said, we can now work towards figuring out how to answer questions like this. But before I do, again, I don't want you to memorize the steps or memorize what to do. I want you to understand it. So let me back up a little bit. Let's move this over to the side. Tell me, what does something like this mean? It means 3 times 5, right? So when I have brackets, so I can have a 3 in bracket, or it doesn't have to be. 3 bracket 5 means 3 times 5. So we know that those brackets mean multiplication. So when I have two things in brackets side by side, it means multiplication. So that tells me that this here means 3 times, and it's not just going to be 3 times the x or 3 times the positive 1, it's 3 times both of them. 3 times both x and positive 1. So we often use arrows to show that we're going to take that 3 and multiply it to the x, and then take the 3 and multiply it to the 1. Okay, so again, hopefully now when you see questions like this, you're not memorizing what to do, but you can decode the math as 4 times that, because we know that brackets mean times. So let me jump back into our main question again here. So if I said, and we call this expanding or expanding and simplifying. So if I said expand this question, I need to first take this 3 and multiply it by x, and that gives me one part of my answer. What I'm then going to do is take that same 3 and multiply it by a positive 1. Now the reason I'm multiplying goes back again to the fact that the brackets mean multiply. So let me write my rough work off to the side. So my rough work here is for that green one, this green arrow here, I'm going to take 3 times x. Now, how do we write 3 times x? We just write that as 3 and x. So anytime you see these combined side by side, it really does mean 3 times x. 3xy would mean 3 times x times y. Xy would mean x times y. Okay, so hopefully that makes sense. So our very first part of this answer would be the 3x. Now, what about looking at this one here? So now I'm going to take, here's my rough work again, now I'm going to take that 3 and I'm going to multiply it by a positive 1, and this gives me a positive 3. Now I can't just put 3 there, otherwise again it kind of looks like 3 times x times 3, so I need the plus to show that I'm adding. So 3 times everything in the bracket means 3 times the x and 3 times the 1. So that's called expanding using your distributive. Why are we learning this? Why is this a handy tool? Because if I asked you to simplify, and again, in our last video, we did things like, if you are following along and copying, don't worry about copying this part down. In our previous video, we looked at things like this. And we said, well, before you can group your like terms, you have to get rid of the brackets. You have to get it out of the brackets. So our rule for that was, if it's positive, get rid of these. If it's negative, you are able to distribute that negative in. Now, once we were able to get rid of those brackets, then we were able to group your like terms and simplify. But what if our question had, let's say, a 4 in front of it? Well, now this is where distributive comes into play, because for this part I can expand using the distributive property. Whoops. I can expand using the distributive property. So again, what this means is I'm going to take this thing that's in front of my bracket and multiply it by each thing in the bracket. So just to make it even more clear, I'm going to start to underline the terms in my bracket. Now each term is separated by a plus or minus. So I have the x term and then I have the 3 term. So to color code it, I'm going to say let's take my 4, multiply it by x. And again, whenever you have a number times a variable, you just write them side by side. This one becomes 4, so my answer would be positive, whatever 4 times positive 3 is. Now you can do that in your head and say 4 times positive 3 is a positive 12, and you can skip that step where you're writing it all out. Okay, so I'll do that. I'm going to erase this and say this becomes positive 12. Now going along with our last lesson, our adding and subtracting polynomials lesson, what I could do is I'm going to say, well, this is the same thing as subtract distributed in here. Now here's another way to look at this. There's always that invisible number in front of a bracket. So we could actually say that we're multiplying in a -1 into the 2x. So here's my rough work for that. And when you've got that, you just multiply the numbers. So I get a -2. And -1 times 1, I get a -1. Okay, there are different ways to do that. Again, in the last video, I wouldn't have done it this way. We would have just said it's a subtract your positive 2x and a subtract the positive 1, which again ends up being the same thing. So when I tidy all that up, I get 4x plus 12. These two make a single negative. These two make a single negative. And now I group my like terms. And I get 2x plus 11. If you're having any trouble with these foundational skills, I have videos on those posted on my channel as well. So again, what's the use of this distributive law? Why are we using it? It's because I can take something that looks more complicated and simplify it into just a polynomial with 2 terms. But I couldn't do that until I got rid of these brackets. Okay, so now that the brackets are gone, I can group like terms and simplify. So what would the formula for the distributive law be? For formulas, we often write them with letters. And basically, the A just stands for anything that's in the spot. In our question here, the A was 4, the B was x, and the C was 3. But this is just a general formula for it. So the distributive law says to expand this, I'm going to take A times whatever B is. And again, when you're multiplying 2 letters, you just write them side by side. And then A times C, which gives me positive AC. So there's your distributive law here. You'll often see it written out this way as well. It means the same thing. So anytime you're asked to simplify and you have a situation that looks like, let's draw that rough situation. You've got something here and then 2 or 3 things in brackets. That's when you're going to use that distributive law to simplify. Your turn. Grab some paper, try part A, and then unpause the video so that you can see me take it up. And if you think you got it all right and you understand it, then move on to B. So pause the video right now, try part A, and then come on back when you're done. Okay, so this is once again a distributive property question. I'm going to say 3 times x is just 3x. And then I'm going to do 3 times -4. Because those signs are different, my answer is a -12. So I have a subtract 12 written there. If that makes sense, pause it and move on to B. All right, so if you've tried B, this question is very similar to A. The only difference is it has a negative in front of the 3. So how does that change things for us? I'm going to do a -3 times x. So again, I'm just going to combine that the number, the -3, with the letter. Here, my rough work is now -3 times -4. Those two signs are the same, so this gives me a positive 12. So that's the only difference between A and B. It's just being careful of those signs. The signs ended up being different. Again, pause the video, attempt part C, and then come on back. So part C is a little bit more difficult, only because I need to multiply 2 times 4x. Now the rule with that is, again, what this means is 2 times 4 times x. So I could rewrite it this way if I wanted to. So whenever you have these questions, you're going to multiply the coefficients, the whole numbers together, and then keep the variable. So this becomes 2 times 4 is 8. I keep the x. And then 2 times -1 is -2. Again, if that makes sense, pause the video and try D. All right, let's take up D. So for question D, again, For part D, this is once again a distributive question. So if you notice, it's in this pattern. This is my 2, this is my 3x squared, this is my 1. So if it's in that pattern, I know I'm going to take this 2 and multiply it to this term, and then I'm also going to multiply it to this positive 1. Okay, so how do I do 2 times 3x squared? Again, I'm going to multiply the numbers to give me 6, and I'm going to keep the x squared. And then my 2 times 1 gives me positive 2. I've got another one for us to try. Again, if you feel confident or if you're curious to see how much you understand, try it on your own first, but I'm going to take it up if you're ready. This question, part E, is once again a distributive question because I have something in a bracket, something before a bracket, and then I have brackets. Now this time I have 3 things on the inside. Now this can either be a plus or a minus. So I have 1, 2, 3 terms, 3 boxes on the inside. But I'm still going to do it the way I did the others. I'm going to take my negative 4 times 3x squared. Now you can write out this step if you'd like, or you can do it in your head depending on your teacher, and negative 4 times 3 would give you negative 12x squared. But I'm going to write those steps out for anyone who might need it. The next one is negative 4 times positive x. So I'm going to do a plus negative 4 times x. I'm just going to link everything with a plus first and deal with the signs later. And then a plus my negative 4 times negative 5. Again, I'm going to multiply the numbers. I get negative 12x. For this one, I'm going to combine my signs and get a negative. So I have negative 4x. And then I get this plus, and this bit here is a positive 20. And again, I'm writing out a lot of extra steps. I'll show you some shortcuts in a second. But what this gives me is negative 12x squared minus 4x plus 20. And that's fully simplified because, again, these are all unlike terms and I can't add them. Another way I like to do it, because I don't like to necessarily have to write out all those steps each time, but writing out those steps do help us to explain what we're doing and why we can take the shortcut. So here's what I tend to I like to just in my head, I'll do this one. I know to multiply the numbers, so that's a negative 12. I keep the x squared. And then for this one, again, I'm just going to multiply the numbers. There's an invisible one there, so negative 4 times 1 is negative 4, and then I keep the x. And then here, negative 4 times negative 5 gives me positive 20. And in that way, you can do that question all in one step. These are going to be the last 2 types of questions I go over in this mini lesson. And the only difference between these examples and the ones we've done above is that the thing in front of my bracket is not a number, it's a variable, which is allowed. And again, it's still following that pattern that we talked about before. So how does that change things for us? Well, we're now going to have to make use of our exponent laws. So in class, you probably would have learned your exponent laws already, but if not, let me just tell you the few that you do need to know. If I have, now we call these powers, a power would be, it would have a base on the bottom and what we call an exponent on top. Sometimes people call it an index, but this is called a base, this is called a power or index, and sorry, exponent or index, and this whole thing is called a power. Now, an exponent law says if I have 2 powers and they have the same base, maybe different exponents, maybe the same, then the rule is that we keep the base and we add those exponents. So in this case, that would be x to the 5. So another example would be if I have x times x. Now, you might already know what to do with that because, for example, 5 times 5 is 5 squared, 7 times 7 is 7 squared, so x times x, it makes sense that it's x squared. But using our exponent laws, we can see why that's true as well. Okay, because I have, there's an invisible exponent 1 here if it's not written. So I can say, well, let's take that common base of x and add my exponents together. So we're going to use these exponent laws to help when we have questions such as the one we're dealing with here. So I'm going to take my x, and I'm going to multiply it by each of these. So here's my rough work for the first bit, x times 3x. Now, with multiplication, it doesn't matter what order you do it in. Technically, I can write it this way. And I'm going to put the number in front, and I'll put the two x's side by side at the back. Now we saw here that x times x is just an x squared. So we end up with this first arrow giving us a 3x squared. And then when I want to do x times positive 1, well, anything times 1 is just 1. So a 1x times a positive 1 is still a 1x. And there's my answer for that one. One more like that. Here's part B. If you want to try to do it on your own, you can. But otherwise, let me take it up with you. So again, we have the same kind of distributive law pattern. I have something in front of brackets. And in this case, I have 3 terms on the inside. So I'm going to have 3 arrows. I'm going to have 3 terms in my final answer. So here's the first one. X times x squared. There's my rough work. And that goes back up to here. Well, because my bases are the same, I'm going to keep that base x, and I'm going to add my exponents, remembering that there's that invisible 1 there. So that becomes x to the exponent 3. So this first portion becomes x times x squared is x to the exponent 3. How about this next one? Now I'm going to do x, or 1x, times negative 4x. So in this case, I'm going to do the numbers together, and then again, I'm just going to stick the x's together side by side. This gives me negative 4. X times x is x squared, so I get a negative 4x squared. And finally, x times a 3, we just write it as 3x. We write the coefficient in front. That's our answer for that one. Your turn. Use the concepts that we learned in this lesson to try to answer these questions. As always, try one question first, come back and see the answer before you proceed to the others. So pause the video right now and try A. All right, once you've tried A, here's your answer. Okay, and you do that because, or you get that because you do 4 times this and 4 times that. Pause the video and try B. Here's our answer for B. Pause it. I'm going to show you the answer for C now. Now C is a little bit trickier. For the full solution for C, I've got that written here. You can pause the video and look through that, and hopefully that explains it for you, but I did want to give you one that was a little bit harder. Pause the video and try D. This is the answer for D. Pause the video and try E. Here's my answer for E. And F is a harder one as well. So pause the video and try it. If you need some help, you can come on back and I'll show you how to get your answer. All right, so here's the answer for the final homework question. How do we get there? Now I do want to explain this one a little bit. We're going to take 2 times 4x squared as my first answer. So what I'm doing is, here's my rough work, 2x times 4x squared. Whenever I have a series of numbers multiplied with variables and letters, I'm going to multiply the numbers first. So 2 times 4 gave me 8. And for my variables, the rule there is keep the base, add the exponents. And so that's how I got this. And I did the same thing for 2x times positive 3x, this one here. I did 2 times 3 is 6. And then I added my 1 plus 1 to give me 2 for x squared. And then for the final one, 2x times negative 1. It's not a subtract, it's a times. So I multiplied the 2 with a negative 1, and I still had the x. So that's how I got that. And that's it. That's for simplifying polynomials using our distributive